this is the task that we use for our mock quantitative. I'm going to go through this mock quantitative, and as I do so, I'm going to use these 20 coins here. 20 coins representing 20 marks. You can see I have a pile of 20 coins there, and as I go through it, I'm going to make some mistakes and give corrections. And each time I make a mistake, I'm going to lose some points into this black box. When I lose a point, it goes in there, and now I can only get 19 marks. Now I can only get 18 marks. That's how it's going to work. Put those back. So I'm going to go through the quantitative, and there are some key points in the quantitative. There's doing the practical, getting the data. Then there is producing a nice table, nice and neat, with good features. And then the graph, doing a good graph that maximises use of the graph paper and it's plotted accurately. And then lastly, the analysis of the graph. So I'm going to go through this, starting with the procedure. So I had a clamp stand, clamp, a boss, a couple of masses, one called M, one called W, and then I have a ruler here pivoted on this dowel, 2 loops of string. Right, let's set this up as the diagram shows. So I need to have the clamp holding this ruler. So let's set this up. I need to pivot this, so I'll be hanging masses on to the ruler, so it will be pivoting around there. So just this. Right, M goes on the left of the ruler, and W goes on the right of it, and the loops of string actually hang onto the ruler. So let's set this up. So I need to balance this. I need to set P, which is the distance between the pivot and mass M, at 10 centimetres. Now it's pivoted at 30, so I'm going to do all, because this is a ruler, I'll just measure directly on here, and that my reference point, my pivot, is at 30 centimetres. So if I put this at 20, then it's 10 centimetres away. And then I need to balance this. Moving this along here. Right, okay, there we go. Now, the first thing is, does that not look like an awkward way of clamping the dowel? And yet lots of students do it. That is not the correct way to clamp it. It's also not what the diagram shows. Now the clamp is shown as a dotted line because it's behind the ruler. The way to actually do this is, if I just hold this steady, rotate this around, and then I'm going to clamp so that the clamp is going around the dowel like this. I just need to give this enough clearance so that it's getting past the screw on the boss. Okay, now that is a much more sensible way of clamping it, I'm sure you'll agree. So I've clamped it now, but that was a really awkward and not very clever setup. So I lost the mark there. My maximum now is, possible maximum is 19. Okay, one other thing to notice about this setup. Why on earth have I got this clamped up right off the desk? Because when this starts to go out of balance, you're going to start cluttering things around. So why not instead move this down? Doesn't need to be all the way up there. That's a much better place for it to be. I only need to give this the masses enough clearance off the table, so that will be a much better place. If that starts to go now, see that will just catch the maths straight on the table like that. So that's much more sensible. Alright, so I can balance this. The first question is to put the P at 10 centimetres and then adjust Q, which is the distance between the pivot and W, so it balances. Don't want them wobbling around when they're actually balanced. So there we go. Still not balanced quite. There we go, that's balanced there. So that's at 39 centimetres. Now we need to take all my measurements down here. So we've got P is 10 centimetres. In metres that would be 0.1. I'll write it up here. 0.100. Q 0. This is 39. Now if I'm at 30 then that's 9 centimetres. In meters. Given the value of W as 0.981, so I need to calculate the value for W times Q. So it'd be 0.981 times 0.090. Because it's 0.981, that's just below 1. I'm expecting a value just below that. .088. Okay. Now the instruction is to change the position of M and adjust the position of W, so that's set new values for M and adjust this W, the Q value, until the rule is balanced again. Carry out the procedure until you have 6 sets of readings for P and Q. Repeat readings are not expected. Record your results precisely and accurately in a table, including your table values for WQ. Right. So what I need to do now is decide what a good range would be. The thing that I would do here is find out what's the what can I go up in. I've got pivot of 0, 30 centimetres is as far as I can go away with P, so I could do 10, could I do 10, 15? No, 10, 15, 20, 25, 30, that only gives me 5, so I could do 5, but then if I'm ending on the 30, that'll be right on the end of the ruler. So that's going to be quite inaccurate, so I won't go up to 30. So I could do, what could I do? 5, 10, 15, 20, 25. No. Okay, so I could do 10, 12, 14, 16, 18, 20. Okay, that's going up in 2, so we'll go for that. I'll write these on the board. So we're going to have P, and it's going to be 100. Oh, okay, we've got 6 readings going up in 2, so that's okay. Right, let's find out what Q is for those. Okay. So 10, so I've got 1 already. So move it up to 2 and rebalance. Doing it carefully just so it's not falling all over the place. Okay, it's balanced. So that's 15.8. Okay. I need these are 2DP, so I'm going to leave that's okay. 10, 1090, 14. Okay, so rebalanced at 21.5. All right, now you would just carry on doing that till you had 6 readings. If I write down what these should be roughly. Okay. Now, before I move on, I need to notice something else. These p-values have only been written down to 2 decimal places. Lots of people did p and q to 2 decimal places. Unlikely you would have done 1 to 2 and 1 to 3. They're both taken with the ruler, so the precision there is 1 millimetre. These all need another decimal place there, and they're all zeros, because they should be exactly on 10, 12, 14, 16, 18, 20. And that's another mark lost there, because I didn't write my p-values to the correct precision. So that's important. Next, WQ. Need to calculate that. Put some lines in here. Alright, so let's put these in. I've got this one already. 0.158. Times in by 9.981 every time. You can see, as I said before, these values are just below the Q values because it's 0.981 I'm multiplying by. There were very few cases where the multiplication was with some other number, not 0.981. I'm not sure what it was and why, but it should be multiplied by 0.981. Right, so I've got my WQ values. Well, that's my table complete. There is, however, one more mistake in that table. WQ needs units, which are Newton meters, because the question said W has a value of 0.981 newtons. So if I'm multiplying it by Q, then force times distance, that's units of Newton meters. That needs to be in there. I've lost another mark. How many have I got left now? I've got 17. That's the maximum of 17 I can get now after making those mistakes. Right, onto the graph. Let's remove this. Right, so we need to keep a record of that data there. I'm going to move the camera. We're back again. I've now drawn up my results onto this table on paper. One other thing to notice about these results is the range, going from the lowest value here to the highest value. So that's 10 centimetres is the lowest, 20 centimetres is the highest. In every experiment, you're expected to use as much of the possible range of values that you can for your independent variable. We could have gone between 0 and 30 centimetres. The question didn't specify how much exactly to use, but in the mark scheme it expected you to have your lowest value as equal to or less than 10 centimetres and greater than or equal to 25 centimetres. So for that reason, because this one is less than 25 centimetres, we would have lost the mark. So my black box is now here and my coins all nicely laid out here so you can see all of them individually. Well, we've lost one of those points into our black box. A range that would have worked to satisfy that requirement would have been starting at 8 centimetres, and I worked that value out by balancing just the mass of the rule with mass m. So I adjusted P until mass m was balancing the other side of the rule by itself. That was 7.4 centimetres. So I went just above that to 8 centimetres and then adjusted W, which is distance Q, until it balanced. So you could have started there and then gone up in 4 centimetres, so 8, 12, 16, 20, 24 and 28. That would have been a possibility. But let's continue with this set of data that we've got here. Right, first thing, we need to plot our label, the axes. The instructions told us to put P on the y-axis. Even though it's the independent variable, that's where it goes. Just a few people put that in the wrong place. And we're going to now put our scale on to here, so we can go 0, 0.1. That's clearly not going to work. I'm not going to have a very good graph if I go 0 and then 0.1 there. So let's go up to there and there. That covers all my points. I'll put this one in for good measure. Alright, let's put the x-axis scale in for WQ. Note that I'm using a sharp pencil. It needs to be sharp because accuracy is important here. I need to work within half a small square and a blunt pencil can prevent me doing that. Right, I've got starting at 0.088, so I'll start at 0 again. And I need to go up to just under 0.45. So 0.5 should cover it. Right, so where would my first point go? It's 0.1, 0.088. So that is just about there. And just quickly see where this one would go. 0.2, 0.441. So it's up here. So going across from the 0.2 to 0.441. Right, before I continue, there's a few mistakes that I've made here. The first one is you need to label every third large square. So this is every fourth large square. That would lose me a mark. This one's okay though, because this is every large square has been labelled there. So I've lost the mark for that. That's sorting out the scales. Next thing is I haven't used more than half the graph paper. There are 12 squares along there, and the vertical separation of these points is 1, 2, 3, 4. Only 4. So that's a third of the graph paper. That's not enough. So I've lost another mark there for not using more than half the graph paper. I'm going to have to adjust this scale. Why did I start at 0? I don't have to start at 0. It's always a good idea if you're quite far away from 0 to use a false origin. So I should put 0.1 down here, or something just below that point, but 0.1 will do. What about the horizontal separation? Well, we've got 1 large, 2, 3, 3.5, we're just over 3.5. That's not a good enough scale either. So I'm going to have to adjust both of these scales. So I'm going to put, if I put 0.1 down here and keep 0.2 there, then I'll definitely be using more than half the graph paper. That'll be 1, 2, 3, 4, 5, 6, 7, 8 squares. That's perfect. So let's rub that one out. I'm just going to have to fill in these labels, obviously. So this is going to be 0.15. So from 0.1. 0.125. What can we do with this scale? I'm on just below 0.1, so if I start 0.05, could keep perhaps 0.1 there. Yeah, 0.1, 0.2, 0.3, 0.4. Oh yeah, that'll be good. So let's rub those ones out there. We've got a false origin here. It's 0.1, 0.2, 0.3, 0.4. Or will this fit in? 0.441? Yeah, because this is 0.45, 0.35, 0.25, 0.15. Alright, so I think that's okay. Now, let's just get my bearings on this scale. 0.1. I think that scale is too awkward to work with. Okay. Gonna start 0.1. Right, that's a better scale to work with. Right, let's rub that one out. Okay, let's put these points. So we've got 0.1 is 0.088. That's about there. Trying to make my plots quite clear, but not too thick. 0.155, so that's there. So each one of these small squares going up here is equal to 0.001, and going across each one is 0.005. 0.14 rather, is 0.211. It's just there. Then 0.16 is 0.265. 0.18 is 0.324. So then that's like there. And 0.20 is 0.441, so 4. Let's check both of those right. 0.18, I think that one is plotted incorrectly. 324. No, that is right. Okay. So it looks like we've got point which is quite far removed. I'm going to, from the trend, I can see that trend going up there. So I'm going to circle that one as an anomalous so I can ignore that for the line of best fit. Okay. Now those 3 points are lining up nice. I'm going to draw my line joining up those 3 points there. So that's my line. I've messed my my points up there. I'm down to 14 points, but I'm about to lose another one because my line of best fit has got 1, 2 points above, but I'm ignoring that one, so I haven't got a fair scatter of points above and below. Then I've got 2 above and none below. I suppose I could have left that one as not as an anomalous and therefore taken it into account, but thus I circled it. So what I should have done, if I'm going to ignore it, is not just join those 3 points because I can, but try and make sure I follow the trend of all the points and have an equal number of points above and below the line. So try and do that the best I can. Something like this. This is coming nearer to the anomalous point anyway. So I've got these 2 are going to be below and 2 above, hopefully, like that. So I've got 1, 2 above, 2 below. Okay, that's the line of best fit. Next I need to calculate the gradient. So here I need to choose my 2 points where the line intersects 2 grid lines nicely. Don't use any plotted points. I'm going to use this point here. Make it clear which points you're using for the gradient. And your read-offs need to be to the nearest half the small square, just as for plotting the points they do. So that's my points there. Okay. And then it's up that way, so that's okay. Right. x1 is the x value here, which is 0.1. x2 is equal to 0.4. And y1 is 0.103. y2 is 0.2. I should rub that out because otherwise it's a not consistent scale. 0.207. 0.207. Let's use the back of this. Gradient is y2 minus y1 over x2 minus x1. Now y2, 0.207 minus 0.103 over x2 0.4 minus 0.1 x1. Calculate gradient. .346 recurring. Okay, so if I state that as my answer, there we go. If I state that as my answer, I lose a mark. Can't have the recurring, that's an infinite level of precision. So I should write 0.35. Okay. So that is the gradient. I'm down to 13 marks now. It's looking bleak for me. Now I need to do the analysis. Right. So for the analysis, first thing I need to, well, technically this is part of the graph work. I need to determine the y-intercept of the line. Let's flip my graph back over. The y-intercept isn't shown there, so I need to calculate it. And I can do it from my gradient calculation. Now, because it's a straight line, this equation applies to it. I can rearrange that. C equals y minus mx. If I know a y value and a corresponding x value, then I can calculate that because I now know the gradient. So I'll use y1 and x1, which I read off from my graph. Let's just check that I get these right. They're over here. So C is equal to y1, which was 0.103 minus 0.35 multiplied by x1, which is 0.1. So that'll be 0.035. Okay, 0.103 minus 0.068. All right, y-intercept's done. Let's go back to this sheet folder so I can do the rest of the analysis. This is the equation that was given to me. That's the equation, and what I need to do is compare that to y equals mx plus c. This is the equation of my line, and because it's a straight line, this equation applies to it. What you don't do here is start rearranging this equation and substituting values in from your graph or anything like that. That's called a substitution method. You don't do that at all. P is y. How do I know that? Back to my graph. P is on the y-axis. X, if I look at my graph, X is WQ. So, X is WQ. Keep messing my points up. Whatever is multiplied by X is the gradient. So this whole term in brackets there is gradient. So I'm going to write down gradient equals 1 divided by mg. And then lastly, whatever is added on this second term here is the y-intercept. So y-intercept is equal to 0.2r divided by m. You need to calculate a value for m. M, if I rearrange this, is equal to 1 divided by the gradient times by g, and r would be equal to m times the y-intercept divided by 0.2. So I've determined what these two equations are from here and then rearrange them. Right, let's give the values. So m is equal to 1 divided by 0.35 times 9.81. Need to give it a unit. The question says that m is, well, we know what m is. M from earlier in the book was the mass that we were hanging on the ruler. Now I've been working in newtons and meters, so this will be the SI unit for mass, kilograms. R is based on the value of m that I calculated and the y-intercept, so it's 0.29 multiplied by the y-intercept, which was 0.068, divided by 0.2. Alright, what do I get marks for? I need to have calculated m correctly, given it a correct unit. So I got that. And I needed to have calculated r correctly and given it the correct unit. This also needs to be in the range of 0.050 to 0.150 kgs, which it is. R was the mass of the rule, and that's how I know that that should be kgs. I also get marked on the number of significant figures that I quoted these two to. These are both 2SF. As long as I give it to 2 or 3SF, then that's okay. And lastly, I need to justify how many significant figures I used for R. Right, so this is based on how many significant figures I've got in my raw data. So if P had a minimum of, let's look at my table, minimum in P is 3SF. Okay, and Q was another measurement I took. Q had a minimum of, well, this one is 2SF. Got to make sure I'm consistent here. Right, so P had a minimum of 3SF, Q had a minimum of 2SF. The minimum SF in the raw was 2SF. So R given to 2SF. Okay, and I'll leave it at that. Problem is that I have left one of my raw values out, so I need to lose another mark. Now down to 12 marks. That's 5 and 5 plus 2, it's 12 marks, 12 out of 20. Because in addition to the P and Q, which I measured, I was given W. I need to include W. So W is a raw value, even though it was given to me and I didn't measure it directly. at a minimum of 3 SF. Doesn't change my justification, but you still need to include all of your raw values. And that is the paper. With all the mistakes that I made 8 mistakes, or 8 marks worth of mistakes. So I end up with 12 marks out of 20. Hopefully, when you come to do it, you'll get much higher marks because you will have paid attention to the mistakes and the corrections.